Hey guys, welcome back to a new video, and in this video I'm going to create a restaurant finder app. Now this application is used to find a restaurant which is present very near to you depending on your current location. So this is an intro and I'm going to tell you one by one what are things I will use in this video, and apart from this there are few small definition I want to give you so that you get a little more idea about it. So first thing which I will use in this project is modularization. Yes, this is a multi-module application in which we have a lot of modules and each module defines its own responsibilities. So I'm going to use here the combined modularization approach. So basically in modularization we have three approaches. The first one is called layer wise modularization, in which we have three layers like data, domain and presentation. Second approach is a feature wise modularization, in which each feature has its own module and everything goes into it. Now the third approach is a very combination of these two. So basically we have feature and each feature contains three layers: data, domain and presentation. So by doing this we have a clear separation of concern, and it also helps us to follow the clean architecture principles. And now the thing is why I'm using this third approach. So basically we have three things which is used to define the modularization is good or not. These three terms are coupling, cohesion and granularity. These three factors is actually used to tell you whether your modularization is good or not. So these three is defined very well for our third approach, which is combined. So that's why I'm going to use this combined approach. Now the second thing is how to manage your build.gradle dependencies in multi-module application. In multi-module application we have a lot of build.gradle file because every module has its own build.gradle file. Suppose if you have any dependencies which you want to use in one file and also want to use that particular dependencies in your other build.gradle, then on that occasion you're going to copy paste that thing, and it is not a good approach. So I'm going to tell you how to avoid this and how to manage your Gradle dependencies properly with the help of Kotlin DSL. Yes, we're going to use Kotlin DSL for managing our dependencies, and it is a very good approach and also it is a very easy to follow. We are going to use clean architecture with MVVM pattern. Now what is clean architecture? Well, clean architecture has three layers in it: data layer, domain layer and we have presentation layer. Data layer has a responsibility of taking data from our remote data source or local data source and get this data to our domain layer. Now the responsibility of domain layer is to write business logic if you have any, and if you don't have any there is no problem. Now move to our presentation layer. Now this presentation layer is actually used to show the UI to our user. So we have our view model over there, we have our fragment, we have our activities over there. So all the things which is visible to our user is going to present in our presentation layer. And also if we have something which is purely related to our framework thing, then that thing is also present in your presentation layer. Okay. So we are going to use Jetpack Compose UI in order to create this application. And apart from this you will learn how to navigate in multi-module projects. So it is a very easy, and I will tell you very easy approach so that you will find a way to navigate in multi-module application. And apart from this we are going to use a lot of flows, like we are going to use mutable state flow, we are going to use callback flow. Apart from this we are going to use debounce in order to produce some throttle, so that if user try to search something, then after a certain period of interval we're going to hit our API instead of hitting our API again and again if user type something. So you will learn how to use this debounce thing with the help of flow. We are going to use Dagger Hint for our dependency injection framework. The most important thing in this application is Google Maps. So I'm going to use Google Maps SDK to render our maps in Jetpack Compose UI. Apart from this, I'm going to use its two more API, which is very important for our use cases. Like the first API is Places API. So Places API is actually used to getting the list of restaurant based on your current location. Second API is Direction API. So Direction API is actually used to find the route from your current location to the chosen destination. Okay, so these three things I'm going to use, and it is super important for our application. Okay, so after reaching to our destination, suppose we reach to our destination, then I'm going to save all the information for this destination in our RoomDB. So we are going to use a RoomDB for that, I mean a local database. So you will learn how to set up our room database in multi-module application, and where is the best place to put our database things. So you will learn also. And apart from this you will learn type converters, what are type converters and why we use them. So yeah, these are the things you will learn in this video, and I'm sure you are very excited, so as I. And make sure to watch this video till end. I will show you the application demo after this. This is our home page, and when I click search icon, uh, we will reach to our places search screen. So first thing, I execute this application for the first time. Then we need location permission, so I'm gonna give this permission, and after that I will click on these three dots which will open this UI, and by using this location thing you will update your emulator location. So I'm gonna update my current location of this emulator to Kisori Southern, and I will choose set location, so it will update my current location. And here I'm gonna type Kisori, so it will give me the Kisori restaurant. I hope it will give, and there we go, we have Kisori restaurant, Bela Pratapgarh, UP, India. So I'm gonna click it, and it will start the direction API. It will call direction API, establish a route from Kisori Southern to the Kisori restaurant, and there you go, you will see all the direction thing over here. Okay, so now again I'm gonna open this, and I will create a route from this point, from our current location to the restaurant. So I already did this from before executing the application. So this is our route, and I'm gonna start routing. Okay, so it will start routing toward our restaurant. So just like this, it will update our UI also. So after we finish our execution, the information is gonna save in our room DB and will again reach back to our home page. So wait for the moment when we reach toward our restaurant. So I'm gonna increase the speed 5x so that it will move quickly. Okay, now I'm gonna reduce my speed. So we successfully reached to the destination. That information gonna saved in our room DB, that is reflected in our home page. First you need to create a new project. So in order to create a new project, go to file, select new project, and you will see this dialog. So currently I'm working with Flamingo, so this is a dialog which I see. So select this empty activity, and if you're working previous version you have empty compose activity, so select that, click on next, and here you need to provide your application name, your package name, location, and minimum SDK. So I already create a project, so I'm not gonna create a new project for that. So I simply close it, and this is my new project. Okay, so now it's time to create few modules. So in order to create modules, go to file, new, and here you will see new modules. Click here and choose this Android library, and you need to provide your module name. So I'm gonna give it dashboard colon presentation. Okay, so each feature contains 3 layers. As I said you, we're gonna follow combined modularization. That means we have feature with layerization. So each feature contains 3 layers: presentation, domain, and data. Okay, so by using this we follow clean architecture pattern. So we have dashboard feature, and within this dashboard feature we have our presentation layer. Okay, and you need to change this package name from com.visionandroid.dashboard. Okay, and simply click finish. So it will create a new module for you. So our module is created successfully over here. So we have presentation layer just like this. We have our data layer and domain layer. So choose this Android library, and here you need to create a data layer for our dashboard feature. So dashboard.data. Okay, click finish. So it will create a new module within this dashboard directory or folder. Here you will see data layer. Just like this, you need to create your domain layer, but we don't gonna use these two layers, data layer and domain layer, in dashboard. You will see why I'm not creating that domain layer. Okay, we have new module Android library. I'm gonna call this common directory, and within this we have utils. Okay, and make sure to add common here. Okay, simply finish it. So it will create a new common directory, and within that directory we have our utils module. Okay, so here you will see. Okay, so like this we have our location feature. So create a location directory, and within this we have 3 layers: data, domain, and presentation. So new module, choose this Android library, and we have location colon. First we have our presentation layer, and here after vision Android I'm gonna change my package name vision Android location dot presentation. So finish it. Here you will see we have location directory, and within this we have our presentation layer. So like this I'm gonna create 2 more layer. The second one is data layer. Change this package name to vision Android location dot data. Finish it. And lastly we have our domain layer. So module Android library, here we have domain. Change this vision Android to vision Android location dot domain. Simply finish it. Alright, so we have these features and its layer. Okay, and now it's time to manage our build.gradle dependencies. Because we have a lot of features, and every time when we need any dependency we need to copy paste in its build.gradle. Because if I open my scripts, you will see we have a lot of build.gradle. So if you want any specific thing here, and also you need to want that thing in our other build.gradle module, so you need to copy paste the dependency. So we're gonna find a way so that we ignore this step. I mean, you don't need to copy paste all the dependency again and again. So I'm gonna show you how you will manage properly your dependencies in multi-module application. So for that, first you need to change your view from Android to project, and within this right click here, create a new directory, and directory name is very specific: build capital SRC, build source. And within this I'm gonna create a file. So new we have file, and the file name is also very specific: build.gradle.kts. so basically I'm gonna use Kotlin for managing all of our dependency. So generate this, and within this you're gonna write plugins Kotlin DSL, and just below to is we have repositories. So I wanna use only Maven Central. Now sync your project, and it will set up all the things which we need. Alright, so our Kotlin DSL setup is completed. You will see our build source is now looking in a different way. Now within this I'm gonna create our new directory, and the directory would be source main Java, this one. And within this I'm gonna create a Kotlin file naming dependencies, and all of our dependencies I'm gonna copy paste in here. Alright, so I'm gonna show you one dependency how we convert that thing, and then after I will copy paste all of the things which I gonna use in this project. Okay, so I'm gonna convert my view from project to Android. Open my Gradle scripts. We have build.gradle for module app level. So I'm gonna copy only this dependency. Go back to your dependencies, and here I'm gonna create an object naming version. Okay, and we have object, let us suppose I'm calling this depths, and I'm gonna create a const val of core. Paste my dependency here, convert this thing in a form of string, and take back my version number. Const val we have core, within a string paste your version code over here 1.8.0, and that thing you will utilize over here. So version dot core. Okay, so now I'm gonna use these steps within our build.gradle. Remove this, use steps dot core. Now simply sync your project. So you see our depths.core is now available. That means the things which we wrote in my dependencies is available to my build.gradle. And one more thing, I copy paste all the dependencies which I'm gonna use in this project, and also there are few more dependencies which I will use in this project, but I'm not sure for that. Okay, so this is the way using which you will manage your dependencies properly. Okay, and one more thing which I'm gonna tell you, in your build.gradle project level, you need to change your Kotlin version from 1.7.20 to 1.8.20. And apart from this, in your module specific build.gradle, you need to change your Kotlin compiler extension version from 1.3.2 to 1.4.6. okay, and your compile options, we have source compilability, and by default it uses version 1.8, but in our case I'm gonna use version 17. okay, so I'm gonna copy paste version 17 in our source compilability and target compatibility, and in our Kotlin option JVM target, I'm gonna change this from 1.8 to 17. okay, so these things you need to change in all of your build.gradle, like for utils, for dashboard data layer, for dashboard presentation layer, everywhere. okay, so I change all of our dependencies in that form so that we'll manage very easily. So this is for our build.gradle module app level. I change everything. And one more thing, these compile options, these Kotlin options, and our Kotlin compiler extension version. And on the top we're gonna use Tiger Hill, so that plugins we need for that. And in our build.gradle, I already add my Tiger Hill dependency plugin. okay, just like this, for our common utils I make all the changes, and your version, your Kotlin options, everything. Then we have dashboard data layer. So dashboard data layer is not gonna use in our project, although I created, but it is not used. okay, but you need to change this source compatibility and target compatibility and our Kotlin options. okay, for our dashboard presentation, you will see everything is replaced in a form, so that will manage very easily. It's compile options, Kotlin options. okay, and on the top we have Tiger Hilt. And one more thing, you need to add its compose options, build features, everything in your presentation layer. okay, so just copy those and paste in here. Otherwise it will basically give you an error. So like this, we have location data, change all the things, it's Kotlin options, compile options. On the top we have Tiger Hill. Like this, we have our location domain, change everything. Here Kotlin option, compile option. On the top we have parcelize, we have Tiger Hill. And like this, we have a location presentation layer, we have Tiger Hill thing, we have our compile option, Kotlin option, and this is presentation layer. So we need to add all those things which I copy paste in here. So copy this thing, go to your presentation layer and paste in here, so that during the compilation you won't see any crashes or error. okay, yeah, that's it. There are few dependencies which I am not converting in this way, so it is your duty to convert everything in this way. Alright, so this is all for managing our dependencies. Now it is time to sync it and start writing our actual code. So first we will handle our navigation. So in order to do navigation in multi-module application, first I am going in my common utils module, and within this module I am going to create a package, and the package name would be navigation. And within this navigation I'm going to create a interface, and the interface name is feature API. And within this interface I'm going to create a function naming register graph, and within this graph I'm going to use my nav host controller. And second is our nav graph builder. okay, so this is an interface, and we are going to implement these interfaces in our feature modules. So now it's time to jump our dashboard module presentation layer, and within this we are going to create a package which is of course related to navigation. So I'm going to name it navigation, and within this navigation I'm going to create a separate interface, and that interface name is dashboard
API, and this interface is gonna use our feature API interface. This is not available because our presentation module doesn't know about common utils module. So what I'm going to do, go in our build script, which is for dashboard presentation, and here I'm going to connect this module with our common utils module. So implementation project, and within this I'm using my common utils. Sync your project and return back to your navigation dashboard API. You can see feature API is available. So import this, and just below to it I'm gonna create a class, and the class name is dashboard API implementation, and this particular class is implement our dashboard API. So control I, and here we have register graph. Okay, so implement it. Okay, so within this particular function, what I'm going to do, I'm going to create one more object, and the object name is internal dashboard movie API. Okay, this is an object, and this particular object is gonna implement our feature API. We have register graph, so basically use this register graph, and within this what I'm going to do, I'm going to use my nav graph builder, and this particular nav graph builder has extension function naming navigation. So basically it will create a nested navigation graph for us. Now the requirement of this navigation function is start destination, and apart from this its route. Like navigation is a nested, so that means navigation graph is also containing his own route. Okay, so these two are constant, so I'm going to create a few constant enums for our this start destination and the route. So go in our utils module, and within this we have our navigation, and within this navigation I'm going to create a file, and the file name is navigation constant, and within this I'm going to create a enum class, and the enum class name is nested navigation route. Okay, we have a constructor, and the constructor contain a route which is a form of a string. So the first nested route will be our dashboard. Enum is based on our location, because we have two features. The first feature is dashboard and second feature is location. So the nested navigation route for our location is location. Now I'm going to create a one more enum class. This is for our feature level navigation routes. Like we have dashboard feature, and within this dashboard feature we have a lot of composables, so each composable contains destination. So for that I'm going to create a dashboard route. Again the constructor will be same, and within this we have only one basically screen, so for that I'm gonna call it home screen, and the name would be home. Okay, now for location we actually have two screens. The first screen is where users see a restaurant, and when they click any of the restaurant we move to our Google Maps screen. So basically we have two screen. So I'm gonna name this location routes. Again the constructor would be a route as a parameter, and it is a type of string. Within this we have our places search, or you can say our restaurant search, and I'm gonna call this places, and the second one is our Google Map, and I'm gonna call this route name Google Maps. Okay, so these are few constant which I'm gonna use in my internal dashboard movie API. So for start destination I'm gonna choose my dashboard routes home screen dot route, and this particular nested navigation contain a navigation route, and its name is would be nested navigation route. We have dashboard, we simply pass the route. Alright, now within this we have a composable, so use that composable and pass your route here. So in my case we have only one dashboard route, home screen route, and when this route is exactly same, we are going to render our home screen composable. So for that, I'm going to create a new package, and the package name would be screens. In this screen, I'm going to create a package, and the package name would be home, and within this home we have our composable. So I'm going to create a file, and the file name would be home screen. This is a file, and within this we have our composable naming home screen. That's it for now. Go to your navigation internal dashboard movie API, and when this route is exactly same, then I'm gonna use my home screen. Alright, now I'm gonna use this internal dashboard movie API to our dashboard API implementation. So I'm gonna use this, register our graph, pass nav host controller and nav graph builder. Okay, so this is all for the implementation part. Now I'm gonna create one more package which is for dependency injection. Right click, create a new object, and the object name would be presentation module. Install in singleton component, and this is a module. So in order to tell Dagger this is a module, please take this as a reference. You need to add this module annotation. Now what I am going to provide here, so in order to provide, we use provide annotation, function provide, and this time I'm going to provide our dashboard API. So dashboard API, return type is dashboard API, and we simply return the implementation of this particular interface. So we have dashboard API implementation. That's it. This is all for navigation in dashboard. Now we have to do similar thing with our location feature. So go to your location presentation layer. First thing first, I'm gonna connect this presentation module to our to our common utils module. So in order to do that, go to its build.gradle presentation. So this one, and here what I'm going to do, in the dependencies I am using implementation project. We have common, and within this common we have utils. Now sync this is completed. Now within our presentation I'm going to create a package, and the package name would be of course navigation. Apart from this, we have second package which is for screens. Okay, so within this navigation I'm going to create a interface, and the interface name would be location feature API. This particular thing is going to extend our feature API which is present in our common utils module. Okay, now below to it I'm going to create a class, and the class name would be location feature API implementation. I'm going to implement this thing. So after this I'm going to create a object, and the object name would be internal location feature API. Extend this, not extend, implement our feature API. Okay, so here we have our nav graph builder. I'm gonna use navigation. We have start destination, and we got route. So in place of route I'm gonna use my nested navigation enum. So nested navigation route dot location dot route. Okay, and within this we have composable. We need to pass route. So this time route coming from our location routes dot places search dot route. Okay, we render our places search composable. We have second composable, and the route would be location route dot Google Maps dot route, and render our Google Map screen. Okay, so start destination will be this one. So copy this, paste here. Alright, so I'm going to create two screens. One is for places search, and the second one is for Google Maps. So within our screen I'm going to create two package. The first package will be places, and the second package would be our Google Maps. Not within our places, Google Maps. Okay, so within these places I'm gonna create a file, and the file name would be places search. This is a file, and within this we got a composable uh, restaurant finder screen. And within this Google map, I'm going to create a file, and the file name would be Google Maps screen. And within this we have composable naming Google Maps screen. Cool. And I'm gonna use these two screen within our location feature API. Sorry, not location feature API, but in internal location feature API. And here we are going to call our places screen, which is a restaurant finder screen. And here I'm gonna call my Google Maps screen. Now use this internal location feature API in our location feature API class implementation. So internal location feature API register graph, pass your nav host controller and nav builder. Okay, this is done. Now I'm gonna create a package, and the package name would be di, because I'm gonna provide this implementation through Dagger. So right click, go to new, create an object, and the object name would be presentation module. Install in singleton component, annotate this thing with module, and within this I am gonna write a provide function which will actually provide the implementation of this location feature API. So location feature API. Alright, return type would be location feature API, and I'm gonna return the implementation. That's it from navigation perspective for this particular module. Alright, now I'm going in my app module, and within this app module I'm gonna create a package, and the package name would be navigation. And within this navigation I'm gonna create a data class, and that data class name is navigation provider. And this will basically take two variables. The first variable which is called this one, the dashboard API. Okay, so this app module doesn't know about these modules like dashboard module, dashboard domain presentation module, and location data domain presentation module. So what I'm going to do, in our build.gradle module app level, I'm gonna call implementation project, and within this first I'm gonna use my location data and duplicate it. We have data, we have domain, and we have presentation. Again duplicate it. After that we have our dashboard, presentation, and also I need to connect this particular module with common. So common utils, sync your project. Now app module know about all these modules. Go to your navigation provider, and here I'm gonna use dashboard API. I think now it's available. And second feature API is location. So location feature API, location feature API. Okay, so we have navigation provider. Now I'm gonna create a package for dependency injection. Right click, create a object, and this time the name would be app module, and I'm gonna install in our singleton component, annotate this thing with module, and within this I'm gonna write a provide function, provide navigation provider. Now the input for this function would be our dashboard API and our location feature API, and the return type would be navigation provider. return a navigation provider object. So we need to pass dashboard API and location feature API. I'm not going to create this particular navigation provider again and again, so for that I'm using singleton. Okay, now within our main activity, we have to use this annotation Android entry point, and after that I'm gonna use field injection and inject this navigation provider. Okay, now I'm going to set up my dagger hilt. So in order to set up, right click, create a new base application, as you already know about this. So we have base application class, and this class extend the application and annotate this with hilt Android app, and register this application name to your manifest, which is base application. We are going to write a small navigation composable. So within our navigation package, I'm gonna create a new file, and the name would be main navigation. Now this is a file, and within this we have composable naming main navigation, and within this we require nav host controller. Within this I'm call my nav host. So the requirement of this nav host is nav host controller, and I'm gonna use here the second constructor, which is taking nav controller and the start destination. So within this start destination, we need to give the nested navigation route. So in order to give the nested navigation route, we have already a enum, so I'm gonna use that enum nested navigation route dot. So first I'm gonna jump in my dashboard, so that means I need to pass the dashboard route. Okay, so now within this nav host lambda expression, what we are going to do, so we need this navigation provider. So take that navigation provider as an argument and use it. So like navigation provider dot, here we have dashboard API. Now that dashboard API contain register graph, and the input of this register graph would be nav host controller and nav graph builder. Now nav graph builder is already present in a form of this lambda expression parameter. Okay, so similarly like this, we have our location feature API, which has register graph, pass your nav host controller and nav graph builder. That's it. This is all for the navigation. Now I'm going to call this main navigation in my main activity. Alright, so from here I'm going to call our main navigation. We need to pass our nav host controller, so just create a nav host controller over this surface. Well, nav host controller, remember nav host controller, no need to pass this navigator, simply use this nav host controller. Sorry, I make a spelling mistake. Copy this, paste here, and second one is our navigation provider. That's it. This is all for the navigation which we need to do in multi-module applications. So now navigation part is done. So it's time to recapitulate what we did in order to perform navigation. So within our common directory we have utils module, and within this utils I'm gonna create a feature API interface. This interface contain a function register graph, and the parameter of this function would be nav host controller and the nav graph builder. Okay, so we use this particular interface in all of our features. Like we have two features, dashboard feature, location feature. So within our dashboard feature we have a navigation package, and this navigation package contain dashboard API, which is an interface, and this interface uses our feature API. That means all the properties that feature API has is now available to our dashboard API. Apart from this, we created a class dashboard API implementation, which is writing the implementation for this dashboard API. Now dashboard API contain a register graph function, and this particular thing is gonna contain all of our navigation logic. So go to your internal dashboard movie API, and here we create a nested navigation, give the route to its nested navigation, and also give a start destination. So we have home screen as a start destination, and our composable is also contain the route dashboard home screen route. That means the first screen is home screen, which is visible for this particular nested graph. Just like this, we have our location feature. So within our location feature, we created a location feature API. It's just a wrapper. We use feature API. Now all the properties that feature API has is available to our location feature API. Now we wrote a implementation for that, and all the navigation logic is present in our internal location feature API, which is an object over here. So again, with the help of NavGraph Builder, we use navigation extension function, and within this we pass our nested navigation route and the start destination for this particular navigation. So start destination is places search route. That means our first screen is this one, the student finder screen. Okay, apart from this, we use dependency injection in order to provide that implementation for this location feature API. Your question is why you created this interface. Basically, it is a wrapper over feature API. If you don't do that, you will write the implementation for feature API. Yes, it is possible, but in our dependency injection, then that particular case we have a feature API is the return type. Now this feature API is also provided from our dashboard, so you need to create a custom annotation for that in order to differentiate between this implementation for the location and dashboard. So that is why I am creating this interface, so that it is very easy for understanding that this particular thing is used for location feature and for our dashboard feature. Okay, so this is a basically use case for this. It's time to create our domain layer and data layer for location feature. So within our location, within our domain, I'm gonna create few packages first. So the first package name was dependency injection, second package name was repository, third was our domain layer model, and the fourth one is our use cases. Alright, so within our repository, I'm going to create a interface, because this interface is going to implemented with our data layer. So the interface name was location repository, and within this function, within this interface, I'm going to create a function, and the function name was get location once, and parameter for this function would be location. This is a lambda expression which has a input of location and output is unit. Okay, next is our search restaurants. We need to pass query, and the return type would be flow. So make sure to import the correct flow, places result. Alright, so this places result is a sealed class that I am going to create in our common module utils. So within our utils, I am gonna create a package, and the package name is events and results. Okay, within this I'm gonna create a sealed class, and the sealed class name is places result. Okay, and within its parameter I'm gonna pass location. Initial value is null, second one is list, which is a type of mutable list of auto complete prediction, and initialize this thing with mutable list of. The third one is message. If anything goes wrong, we need to pass the message, and initialize this with null. And within this we have a class for our success case. So if it is a success case, we got location, and also we got a list, which is a type of mutable list of autocomplete prediction, and extend this with places result, pass our location and list. Okay, second one is our loading state. So in our loading state we don't pass anything, we simply extend our places result. Next is our ideal case. So again, no need to pass anything in its constructor. The last one is our error. So in error case we got a message, type is string, and extend this thing with places result, pass message in it. So this is a sealed class. Go to your location repository, import it. Now it's time to implement this interface in our data layer. So first I need to connect our data layer to domain. So go to build.kedal for data layer location, duplicate this location and domain, sync it. Go back to your data layer module, and within this data layer I'm gonna create few packages. So first package would be for dependency injection, then for our repository implementation, and after that we have something which is called models. Okay, so within our repository I'm gonna create a class, and the class name would be location repo implementation. Okay, this will implement the location repository once this Gradle build sync completed. Here it is. So we have location repository, and within it we have two functions, get location once and search restaurants. So within our get location once, we are going to use fuse location provider client, because with the help of that we get a current location. So I'm gonna use constructor injection, pass our private while fuse location provider client, import this inject, and now it's time to use this thing within our get location once. So remove this to do, and here I'm going to use fuse location provide request location update. So within this we need to pass location request and the location callback. So we need to create that. So first I'm going to create our location call back. So create an object for that location callback, and within this we have on location result. So every time when our fuse location product client generate a result, that result is gonna come in our on location result function. Okay, so we got a result, and I'm gonna remove this thing and use our location lambda, invoke it with the help of our p0 location. Alright, so this is the implementation of our on location result. Now we are going to create a location request. So we have a location request. With the help of location request, make sure to import the correct one, and the correct one is com.google android gms location. So use its builder, and here you need to pass the priority. So pass priority high accuracy and pass your first interval. Then we need to set up our interval in millis, which is 1 second in my case. And apart from this, we only want location update for once. So we use set max update once, and lastly build it. Okay, so now we have our location request, location callback. So simply use this within our request location update. So location request callback, in the looper pass null. So this thing require permission, access course location. So we are in a repository and we don't take any kind of permission here. So I'm gonna use here suppress missing permission. So it will remove this error. Okay, apart from this, I'm gonna create a private val current location variable here, which is a type of lat long, and initialize this lat long with lat long. We have 0,0 latitude and 0,0 longitude. Now every time we get the location update, we simply update this current location. So make this var, and here once we got the location update, we use current location, create a new lat long, it dot latitude, it dot longitude. So by doing this, we get a reference of our current lat long within current location. So this is the implementation of our get location once. Now it's time to implement our search restaurants. So this search restaurant is actually uses the Google Places API. So in order to use Google Places API, we need to inject Places client here. So private val places client. Okay, Now remove this thing. We have places client dot find autocomplete prediction. This is the function which I am gonna use in order to get the restaurants. So the input of this function is find autocomplete prediction request. So it require a request. So I'm gonna create that request. So it is find autocomplete prediction request. We have builder pattern here. So we first set our session token. So in order to create session token, we are going to use autocomplete session token dot new instance. So it will generate a token for us. So simply pass your token here. Now we need to set up our countries. In which country you want to search the restaurants. So in my case it is India, of course. Alright, so after that we need to set up our query. So pass your query here. Apart from this, you need to set up the filter type. So set types filter. This is a mutable list of. So basically we want only restaurant. So I'm gonna pass only a restaurant. And lastly, we need to restrict the location because we don't want to search all of our word. We only want to search a particular area which is depend on the user current location. So I'm going to create this location restriction and pass this location restriction within this set location restriction. So for that I'm gonna create a variable naming location restriction. Find location restriction, and within this we need to pass location. So how I get the location? Well, we already create that thing, get location once. Simply cut this out, paste in here. Now we have a location here. Use this location within this. Okay, and here we need to pass the origin. Basically it asks you for the current location, so use lat long. Now we have location, so pass location dot latitude, location dot longitude. Got it. Now it's time to create this find location restriction function. So alt enter, create function, and return type is location restriction. Alright, so within this function I'm gonna take a leverage of rectangular bound new instance. Here we need to pass the southwest and the northeast lat long. So just pass your lat long. So we use this location dot latitude and minus 0.9 in it. Similarly we have location dot longitude and simply minus 0.9 in it. Okay, duplicate it and this time remove this signature and make it plus. So it will basically create a square. Depend on your current location. So I will tell you how it is working, but before that let me finish this. So location restriction is used here, and that's it. Lastly build it. Okay, so now we have a request. Use that request here. Add on success listener. So now it's time to send the event from this function. So how I'm gonna send this, because I don't create a flow. So what I'm going to use callback flow. So by using callback flow it is very easy to convert this type of function in a form of flow. So just see this, try send. Use places result dot success and just pass your location and your autocomplete predictions. If it is a case of failure, then again use try send, places result, error, and this time we need to send the message. Convert this in a form of string. Alright, so this is all for this particular search restaurant function implementation. In this image you will see a Cartesian plane, x-axis and y-axis. So I want to wrap this particular origin with a square. So how do I do that? So it is very easy. Just move 1 unit along the x-axis, 1 unit along the y-axis. You got this point. Similarly, just move -1 unit to our minus x-axis and then -1 unit to our minus y-axis. Now simply connect these points, so it will create a square. So this is a similar thing which I already did in here. Okay, so just see, this is an origin. I differentiate a few constant. This is another point. I differentiate a few constant. Like this we also did this thing. So it will basically create a square. So this is a use case for this fuse find location restriction. Alright, so now we already create this implementation for get location once and search restaurants. Now it's time to write a dependency injection module for that. So right click, new, create an object, and the object name would be data module. Install in the singleton component. This is our module, so annotate this thing with module. Now we require two things. The first one is fuse location product client, so I'm gonna create a singleton for that. Provide function provide fuse location provider client. Okay, so requirement is application context, and the return type is fuse location provider client. Return location services dot get fuse location provider client, pass your context. Like this, I'm going to create a places client for us. So provide function provide places client. Okay, now within this we are going to use places dot initialize. Requirement is context, so I'm gonna use my application context. Pass your context here, and second one is API key, so pass your API key. And now return the places dot create client, and again pass your context. So it will basically create a places client. Now the return type is places client. Cool. So we're done with this fuse location product client and the places client. Now it's time to provide the repository implementation. So I'm gonna use provide function provide location repo, and the output is location repository return location repo implementation, and the input is fuse location product client, and we have places client. Pass both of this in here. Alright, so we have done with our data layer. Now go back to your domain layer, and within our domain layer I'm going to create a use cases, and that use case name is search restaurant use case. Search restaurants use case. And within this I'm gonna perform constructor injection and pass our repository private val location repository. And here I'm gonna create a operator function invoke, pass our query in a form of string, use our location repository search restaurant, pass your query here. So I'm gonna provide this particular use case from dagger hilt. So create a object, and that object name is domain module. Install in singleton component class module, and I'm gonna use provide function provide search restaurant use case, and the dependency for this is location repository, and return type is search restaurant use case. Pass your location repository and change the output. Cool, we are done with our domain layer part. Now it's time to jump into our presentation layer. So within our presentation layer we already did this screen things. We have our places screen. Now I'm gonna create a view model for this. So we have places search view model. I think I forgot one thing in our repository implementation. So within our callback flow, when you use callback flow, make sure to call this thing also, otherwise it will crash your application. Await close. Okay, so now jump back to your view model, and here I'm gonna extend this with view model, annotate this with hilt view model, and I'm gonna perform a constructor injection here. So for that I'm gonna use inject constructor private val search restaurant use case. Import this. Alright, so here I'm gonna create a function search restaurants, pass your query, and I'm gonna use view model scope dot launch, and within this I'm gonna call my search restaurant use case, pass our query, and collect the latest changes or the latest emissions. So it will emit places result. So in order to capture that thing, I wanna create a private variable naming search, which is a type of mutable state of not flow, mutable state. Import this, and within this the type would be places result. Okay, initialize this thing with mutable list of places result, and you need to pass the initial value, so it is places result dot ideal. Okay, I think, okay, sorry, this is not a mutable list, this is a mutable state of. Import this mutable state. Now it's cool. So I make a spelling mistake here, SEAR. Sorry for that. This is a very important thing, well, search, we have state, and the type is same. Use the getter and initialize this thing with underscore search. Import this state. Alright, cool. So every time when I get the emission from our use cases, I'm gonna use my search dot value and update it. Alright, cool. Now it's time to go in our places screen. Now here the first thing what we need to do is taking a permission. So in order to take permission, I use a library which is coming from Accompanist. So I'm gonna create a variable permission, remember multiple permission state. Within this we need to pass a list of, and a list of permission basically. So first one is our Android manifest permission. We have access course location, just like this. We have Android manifest permission access find location. Although this is an experimental API, so you need to annotate this thing with experimental permission API. Apart from this, I'm gonna use our view model as a parameter. So that view model is places search view model, and I'm gonna change this thing within our internal location feature API. So here I'm gonna create a variable naming view model, which is initialized by with the help of hilt view model, and type is places search view model. Simply pass this view model within our restaurant finder screen. Okay, jump back here. Alright, so yep, so if it is a case that our all permission is granted, then we need to do something else. If it is not granted, then on that occasion I'm gonna use launch effect, call unit, so basically pass unit, and here I'm using my permission launch permission request, so that it will show our user we need this permission. If you gonna give me permission, then I will show you, otherwise we don't show you. Okay, so we have all permission granted right now. So I'm gonna create a variable, and that will store the list which is coming from our view model dot search dot value. So this is not list, this is a places result. Okay, so now depending on the places result state, we actually render our screen. So we have few type of state for our places result. The first one is our loading. we have success, we have error, and we also have ideal. So for error, I'm pretty sure this is very easy. Just create a box, and that box has a modifier of fill max size, content alignment in the center, and lastly just create a text and pass your message like places result dot message dot to string. Okay, so for our loading case, I'm gonna simply copy this, paste in here, remove this text, and use circular progress indicator. And for success case, I'm gonna create a constraint layout that contain a text field on the top or search bar, and in the bottom it contain a lazy column. All right. Okay, so I'm gonna create a constraint layout. We have modifier fill max size, and within this I'm gonna create a variable, and the variable name is search cons and list cons. We have create refs, which create a references. Now we have text field, so ignore all this thing, use modifier here. So modifier fill max width, and we have our constraint as, so this constraint as search constraints, and within this I'm gonna start the linking part. So I'm gonna link the start part of this text field to parent start, end part parent end, and top is linked to the parent top. Cool. So this is for our text field constraints. Now we need to use this value and on value change thing. So in order to use this thing, I'm gonna create a variable within our view model. So we have private val underscore query, which is a type of mutable state flow. Type is of course string, and I'm gonna initialize this thing with mutable state flow of empty string. I'm gonna create a query which is a type of state flow. It's a type of string get underscore query. Now it's time to update our query. So pass query and update our underscore query value with the help of this. Okay, so by doing this, we need to do something else in order to search the restaurant. So we create an init block, and within our view model scope, I'm gonna launch a coroutine scope, and within this I'm gonna introduce throttle in our query and then collect it. And once I get the query, I simply call our search restaurants. Okay, now I'm going to use all this thing in our places search. So within our value, before writing our value part, on the top I'm gonna create a variable query that is initialized with the help of view model query dot collect as state, so that if anything get changed in our query, it will reflect in our compose. So here I'm gonna pass my query value, and within this on value change, I'm gonna use my view model dot update query and simply update our query. All right, so this is also an experimental API, so you need to add your annotation experimental material 3 API on the top. Okay, so this is all for our text field. Now it's time for our lazy column. So within this lazy column, I'm gonna use its modifier constraint as. So we have reference, and the reference is list cons, and here I'm gonna use start, link it to its parent start. We have end, link to parent end, we have top, which I link with our search constraint bottom, and we have the bottom which is linked to the parent bottom. Okay, so when it's come to height, I'm gonna use dimension fill to constraints so that it is not present on the center. Okay, so we did this, and apart from this we use items, and that items is coming from our places result dot list. Okay, import this. Now one by one I am getting my restaurants which I find from our Google Places API. So I'm gonna use a simple text and use it dot get full text, pass null here, use toString, and use modifier so that it is appear in our all width. And I'm gonna give some padding to it like 12 dp. Okay, so import this dp. Alright, I think it's done. The presentation layer is also done. So what I'm going to do, I'm gonna tell you how you can put your API key. So in our data layer, data module, you need to put your API key here first, and within our manifest, within our app module manifest, to add this metadata and provide your API key over here. Okay, so I'm gonna add all the API keys, and then after I execute this application in my emulator. Our app executed successfully. This is a permission, so I'm gonna give it, and this is a problem. For the first time when you give the permission, then this success state is never called because we don't call the query, we didn't call our use case. So this is a reason why you will not see anything here. So what is a fix for that? So it is a very easy, just put your constraint layout out of this places result thing. Okay, so I'm gonna do that. So in order to do that, I'm going to create a constraint layout here and just copy all these stuffs like we have here, this thing. Okay, so cut it here and paste within our constraint layout, and within our constraint layout we have modifiers, so just cut out the modifier, paste in here, and remove this constraint layout from success. In this constraint layout I'm gonna put our when expression, so cut this out and paste it here. Now you will see there is no error, and this is a fix for that. So again, open your emulator, go back, uninstall this app, and execute again. And if you click on this three dot, it will open this interface, and with the help of this interface you will set your location. So I'm gonna set up this point as a my current location for this emulator. There you go, application executed successfully. This is our first time and it will ask the permission, so give it permission. Okay, so permission is granted and you will see our text field. Now within our text field I'm gonna type Kisori, and based on the location it will give me the results like this one. So we have Kisori, Bera Pratapgarh, which is very near to me, which is I think a kilometer far from here. Okay, so I think this is a complete implementation of our Places API. You will see how to integrate Places API with our multi-module applications, and yeah, this is our Places API integration. Now we will continue with our Google Map part. So if user click any of this restaurant, we simply start the route from the current place to the restaurant. So it will create a route and when you navigate through your route, it will automatically update that route. So we will do that. So we are done with our places API. Now this places API return autocomplete prediction object, and within this autocomplete prediction object we receive the name, full name, and we receive the places ID and few other information which is not very relevant to us. We require the restaurant, destination, latitude and longitude. We require its name, its address, whether it is opening or not, delivery is available or not. So all this information we require, but with this API we are not getting that particular detail. So in order to get that detail we need to hit another API. So let's integrate that API. So in order to integrate that API, go to your location repository interface, and here create a function naming fetch place, and we need to pass the place ID. This place ID we receive with our places API, and the return type of this thing is flow, and within this flow we have place details. Now this place details is a model, domain layer model, which I'm gonna create in our model package. So right click, new, choose a data class and give a name to this particular data class is place details. Okay, create it. Now within this I'm gonna store my place ID first. Type is string, of course. Second one is name, which is a type of string. Third one is the destination, of course. So we have destination, type lat long. And the fourth one is our origin, I mean where we start navigating. So lat long. And apart from this, delivery is available or not. So type is boolean. Then we have something which is called rating, and this is super important. Okay, so we have this information. Now we require this information, so hit that API and collect all the information which we require. So import this places detail here, and now it's time to implement this particular function in our location repository implementation. Go here and control I, yes. Now we are going to use our places client. So we have places client here, and yes, we got a function fetch place. Now fetch place require fetch place request, so we need to create that request. So within here I'm gonna create a variable naming request, which actually store our fetch place request. Now here we need to follow the builder pattern. So pass your place ID, and the second parameter in this builder is places field. So the information which you require through this API you need to pass in a form of list, like I'm gonna show you. So we have here places list of, and I'm gonna use my place field. Let me import the place. Okay, now you will see we have delivery, rating, phone number, address, lat long, everything what we need. So we first choose our delivery, then I'm gonna choose my lat long, then we choose our what to say, we have address, and we have phone number, we have its lat long. I think I already did lat long. Yes, I did. So apart from this, let me check my places detail. Okay, we did name, destination, origin is not available by this API, delivery, rating, yes, we actually get all the information. Yeah, so keep it very simple. So remove all this thing. So we require this information from this API. Now it's time to pass the places list. Okay, so this is our request. Now I'm gonna pass this request in our fetch place and attach add-on success listener. So within this add-on success listener we're gonna get fetch place response, and within this we have place. Now it's time to map this place with our places detail over here. Okay, so in order to map, I'm gonna create a mapper package here. Right click, new package, right click, new package, mappers, and I'm gonna call this file as a mapper. Within this I'm gonna create a function place to domain. A return type would be place detail, return place details. So we need to pass the place ID. So for now I'm gonna pass my place ID as an empty string. Okay, so we have name, So pass name here with the help of our place object. So we have place name or empty. Okay, so we have destination. So destination is coming from our place, this dot lat long, and we have origin. So for the time being, I'm gonna initialize with the lat long 0, 0 and 0, 0. Okay, so delivery is available or not. So in order to check the delivery, we use this dot delivery, and we need to check it. If it is equals to place a boolean place attribute value true. Okay, last thing is rating. So rating is also coming from this dot rating. So it is a type of double, so convert it in a type of float. Okay, so if any case it is coming null from our backend, so I'm gonna give it 0f. Okay, so this is a conversion of place to place detail. Now jump back in our location repository implementation and simply use this to domain. Okay, now I'm gonna use callback flow here, and within this add on success listener, I'm gonna use try send and simply pass this particular conversion which we did. Okay, now I'm gonna use this fetch place in our view model. So within our presentation we have screens, and within our screen we have places and places search view model. So here I'm gonna create a function that spell fetch details. We need to pass the place id, type is string, and yes, in order to use that thing, we first create our use cases and then inject that use cases in our view model. So come back in our domain layer, and here I'm going to create a use case for that. So the use case name is fetch restaurant details. Okay, this is a class, and within this I'm gonna inject my location repository. Okay, let me import this inject, and within this I'm gonna create a operator function invoke. Within this we need to pass place id, because the requirement of our function which is present in a location repository is places id. So we need to call this fetch place and simply pass our place id here. Okay, so this is a use case for fetching the restaurant details. Now in order to use this, we need to provide this in our domain module. So here I'm gonna use provide function provide restaurant details use case. Okay, so the requirement of this use case is location repository, and the return type is fetch restaurant details. Return fetch restaurant details, pass your location repository. Okay, let me rename this to use case. Now it is more suitable name for our use case. I'm gonna inject this fetch restaurant detail use case in our view model. So private val fetch restaurant detail use case, and within our function I'm gonna use view model scope dot launch and call this fetch restaurant detail use case. Requirement is place id, so pass it and collect the latest emission. Okay, so I'm gonna emit this emission with the help of lambda here. So I'm gonna call this result, and within this the input would be place result, and this function will return unit. Okay, so I'm gonna use this result dot invoke and pass our places details. Okay, so I need to change this to place details, sorry for that. Yeah, now it is good to go. So this is a complete implementation of getting complete details with the help of our place id. Okay, so where do we use this? So we are going to use in our place search list item. So here when our user click on this text, so I'm gonna make it clickable, and when user click onto this, I'm gonna use my view model dot fetch details, and pass our place ID, and when we receive the result we simply navigate to our Google Maps screen. So this is a complete implementation of getting the details, complete details with the help of place ID. So now it is a good time to start integrating our direction API. So direction API is used to find a route between our current location to the restaurant. So let's start integrating that thing. So for that, this is our direction API. So I'm going to copy this, and within our data layer I'm going to create a package, and the package name would be data source. And within this data source I'm going to create one more package naming network, and within this network I am going to create our service. So as you know, we are going to use retrofit. So retrofit require an interface that is implemented by him. So I'm going to call this interface as a location service, and within this service I'm going to paste my direction API. So this direction API contains some base URL. So I'm gonna copy the base URL, jump into my data module, and within this module I'm gonna create few annotations so that we will distinguish between our normal string and our Google base URL thing. So in order to create a custom annotation, you are going to use qualifier, and within this qualifier we have retention, and within this we have annotation retention runtime that I will consume, and here I'm going to create my annotation class. So this thing will call direction API base URL. Okay, just like this I'm gonna create one more annotation for our retrofit. So qualifier retention annotation retention dot runtime, and this time the annotation class name would be location retrofit. Okay, now I'm gonna use these two annotation here. So first I am gonna consume my direction API base URL. So direction API base URL provide function provide direction API base URL. Okay, the return type would be string. Now simply return our base URL. Okay, after this I'm gonna create my retrofit thing. So provide singleton, and my annotation would be location retrofit function provide location retrofit. Okay, and this time I will use my direction API base URL within this. So in order to separate the normal string and this particular base URL, we are going to use our direction API base URL thing, and I want to call this string, and the return type would be retrofit. Return a retrofit builder. Here we have our base URL which I pass here, and we have our converter factory. So I'm gonna utilize json converter factory dot create, and yes, lastly I'm gonna build this. Okay, now I will provide the implementation of this location service. So provide location service, inject our retrofit here, and the return type would be location service. Import this location service, and I'm gonna return the implementation. With the help of retrofit we are gonna write the implementation for this location service class.java. Okay, so that's it for the module part. Now I will come in our location service, and here I'm gonna create a suspend function get direction, and within this I'm gonna annotate this thing with get because this is a get request. Import this get. Now from https to googleapis.com/ is a base URL. Rest all the thing is our endpoints. So I'm gonna copy this endpoint from maps to JSON and paste here. Apart from this, you will see we have few queries, like we have origin, we have destination, and we have our API key. So I'm gonna create few queries for that. So we have query. The first query is our origin, type is string. Then we have second query, which is for our destination, type is also string. And lastly we have our key, API key, basically key type is also string. The return type, I will give you a JSON response which is coming from direction API. So this is a response which I will give you in my GitHub repository. So you will copy all this thing and create a model which is purely reflecting this JSON. So within our model, right click, new, use Kotlin data class file from JSON, paste here and call this direction API response. Okay, so it will generate a lot of classes for you, and use this thing in our location service. So we have direction API response. Okay, that's it. This is all for the integrating thing. Now we are going to utilize this location service in our repositories. So go to your domain layer repository. So within our domain layer we have our repository, and within this repository I'm going to create a suspend function naming get direction, and within this the required thing is starting point, which is a type of lat long. Second we have destination, type is lat long, and lastly we have API key, and the return type of this thing is detail, not detail, it's direction detail. So direction detail is a domain layer model. So I'm gonna create this thing naming direction details. So this is a data class, and within this data class the first parameter is points, which basically contain the mutable list of lat long, and we receive this thing from our direction API, and I'm gonna initialize this thing with mutable list of. Second is distance, so this thing is also coming from our API. Then we have duration, type is string, and lastly we have HTML. So this will show us the turning point. Basically it will give you direction from where you need to turn, from where you need to move right, left, and whatever. So it depends on your route. So this HTML is also coming from our Google API or direction API. So within our location repository I'm gonna import this direction detail because it is created, and time to implement this thing within our repository implementation. So go here and implement this thing. So in order to implement get direction we need location service, so inject that location service within its constructor. So private val location service, and when you change the constructor you need to also change within its module. So within its module here we need to use our location service and pass within its constructor. Okay, so one more thing I forgot to add within its within our retrofit. I'm gonna use location retrofit in order to distinguish between our normal retrofit and this location retrofit. Okay, so now within our implementation part, within our get direction I'm gonna create few strings. So string first is start lat long. This is a type of string, so I'm using string, empty string, and within this empty string I'm gonna use my start latitude comma start longitude. Okay, duplicate this thing. Just like this we have our destination lat long, so destination lat long, and replace this start with destination lat long. Okay, now I'm gonna use my location service dot get direction, and in place of origin I pass my start latitude longitude, in place of destination I pass my destination lat long, and in place of key I pass my key, you pass your key. Okay, so the return type of, or you can say the response from the repository is direction API response. So I'm gonna use mapper and map this direction API response to our direction details. So in order to do that, go to your mappers, and within your mappers create a extension function over direction API response to domain, and return type of this function is direction details. Create an object of this direction detail, and for our points use polyline util decode, and here you need to pass the path which is coming from our direction API. So within our direction API response we have a route. Select the first route because first route is more accurate. Okay, now within this you will see this over view polyline. Okay, use this, and within this you got a point, so pass this point within our poly util dot decode. So it will basically decode all the string and return you the mutable list of latitude and longitude which we are gonna consume in our screen. Okay, so apart from points we have distance. So in order to use distance, use this route, select the first element, and within this we have legs. Select the first one, and within this leg you will see we have distance, we have start address, we have end address, so we have everything. So I'm gonna use distance and convert this thing in a form of string. Like this we have duration, this route, choose the first element because first element is more accurate, that is why always choose the first element which is coming from our API. Okay, within this route first element we have legs, choose the first one and choose the duration. Okay, this route first element we have legs, select the first element within this array or list, and within this we have steps. Okay, select the first element within our step, and here you will see HTML instruction which is a form of string, so use this. Okay, so this is a conversion, or you can say mapping from direction API response to direction detail. Now I will use this within our implementation. So we have wall response. Now I'm gonna return this response to domain, and that's it. This is a complete implementation of our get direction API. Okay, it is time to create a use case for this direction thing. So within our domain layer use case, right click and create a class that will say itself get direction use case. This is a class, and within this class I'm gonna inject my repository. So private val location repository, and within this we have operator function invoke, and the parameter for this is starting point which is a type of lat long. We have destination, type is lat long, and lastly we have API key string, and I'm gonna use flow builder here, and within this flow builder I am going to pass my type. So my type is UI event, and within this UI event we have direction details. So UI event is not created yet, so I'm gonna create this thing within our common module. So within our common module we have package events and results. So right click new, create a sealed class naming UI event. Okay, so this is a generic class which is having type T, and within this we have data type T which is equal to null, and second thing is message type is string, this thing is also null. And within this I'm gonna create few classes. So we have loading, type is T, extend this with UI event, type is T. Okay, like this we have success, and in success case we receive data. Extend this thing with UI event and pass data, and lastly we have error type T, and in case of error we got a error message and pass that error message to our UI event. Okay, so this is our UI event sealed class. So import this and within our flow, first I wanna emit my UI event loading case, then I'm gonna emit my success case, and within this success we have data. So use my location repository, get direction, pass my start, destination and key. And if anything goes wrong here, so I'm gonna catch that exception, use our UI event error class and pass the message. So message is equals to it message to string, and I wanna execute this flow on dispatcher.io. Okay, so this is our use case. Now I will provide this use case with the help of our module. So within our location domain dependency injection module, I'm gonna write a provide function. So provide function provide get direction use case. Okay, and the parameter for this is location repository, return type is get direction use case, return get direction use case, pass your location repository. So this is our use case. Okay, so our use case is done. Now it's time to create one more function within our repository that is used to get the actual location update to our screen, so that we will update our camera position, our tilt, our bearing, and apart from this we also update our route, or what are the remaining distance we have depending on the user current location. So we require a function which is purely give me the location updates that user is now here, now present here after some time. So in order to do that, within our location repository I'm going to create a function naming get location, and within this I'm going to pass a destination which is a type of lat long, and the return type of this thing is flow, and this flow is containing location event. Now this location event is a sealed class that I will create within our common event and result package. Right click Kotlin class /file, we have location event. Now this is a sealed class, and within this we have location. So location which is coming from android.location package, and within this I'm gonna create a class location in is progress, location in progress, not is progress. So within our sealed class, the first class that I will create naming location is in progress. So in this scenario we receive a location and extend this thing with location event and pass your location here. Okay, and one more thing, initialize this thing with null in initial case. Okay, so we have one state where we say location is in progress. Now second is user reach to the destination, so that means reach destination. Again extend this thing with location event and pass nothing. The last one is ideal case, so ideal location event. So this is our location event which contain 3 events. The first one is user in location is in progress, that means user actually running towards our restaurant. And the second one is reached destination, that means user reached to its destination. Third one is ideal case. So within our location repository I need to import this, and it's time to implement the get location within our implementation part. So within our data layer repository implementation, I'm gonna implement that function and start implementing it. So in order to implement this thing, we have use location provider client, request location update. Now this thing require two thing location request, location callback, and your looper. So I'm gonna create location callback. So location callback, type of object location callback, and within this we have on location result. So after I getting the result, the first thing I will change the name location result. Okay, Now here we have current location, and within this we have latitude and longitude. So I'm gonna update this thing first. So we are going to use a lat long, and within this I'm gonna use my location result locations get latitude. Second one is our longitude. So get the first element and its longitude. So our current location is updated. Now we are gonna use callback flow, and the type of this callback flow would be location event. Okay, now within our on location result I'm gonna use try send, use location event, and within this location event we have location is in progress, and pass your location within this. But the problem is, how do I know that we are not present in our destination? I mean, we are in the middle of our route. How do I know? So in order to know that we are present in the middle of our route or we reach to a destination, I'm going to create one more function. So private function is reach to the destination. Okay, so here I need to pass my current location and my destination. So I say current location as origin, type is lat long, and we have destination, that is a type of lat long, and the return type of this thing is boolean. Okay, so here I'm gonna create a array which is a type of float array, contain only one element, and I'm gonna use my location dot distance between function, and within this you need to pass your start latitude, start longitude, end latitude, end longitude, and you need to pass your float array. So in order to pass that, we are going to use our origin latitude, we are going to use origin longitude, and apart from this we have destination latitude and destination longitude. In place of array you simply pass your array. Alright, so reformat it, and you got your result, I mean the distance, which is present in your array that we pass here. So now if our array first element is less than or equal to 5f, that means we are present in our destination. So it will give you a true result. If it is not, it will give you a false result. So I'm gonna use this is reach to the destination function within our this particular function on location result. So if is reach destination, so I wanna pass my current location and I wanna pass my destination. If it is true, that means we reach to the destination, otherwise we won't. So I'm gonna use else, and within this else just pass this try send, and if we reach our destination then I'm gonna use try send location event reached to the destination. Okay, in our location is in progress, I'm gonna use my location result dot location and pass our first result through this. Alright, so we did everything, we got our location callback. Now it's time to create a location request. So we have a location request dot builder, and within this you need to pass the priority. So priority is high accuracy and interval is 100 milliseconds. Apart from this we have to set up our interval in millis, so I wanna use 5 seconds here, and yeah, simply build it. Now use this location request and location callback within our request location update. So here we need to pass location request, location callback, and I am not using any looper, so pass null in place of looper. And when if everything is done, we are gonna use await clause and use our fuse location product client and remove our location callback. So remove location updates and pass your location callback here. So this is a complete implementation of our get location function, which is present in our location repository. Now we are going to use this thing within our view model, or you can say Google Maps view model. So now we will create a use case for this location thing. So within our domain layer use case, I'm gonna create a class, and that class name would be get location updates use case. And within this, I'm gonna use constructor injection, private val location repository, and operator function invoke. Just need to pass our destination, type is lat long, and I'm gonna utilize my location repository dot get location, pass our destination in it. Okay, so this is our very simple use case for this location update thing. Now it is a time to write our Google Maps view model, which we are going to use in our Google Map screens. So within our presentation layer, we have Google Map package, and here I'm gonna create my Google view model. Okay, so this is a class, and that class extend with view model, annotate this thing with hilt view model, and I'm gonna use constructor injection here. So inject constructor private val. So basically we have two use cases. The first one is used for location update, and the second one is used to get the direction route basically. So we have get location update use case, private val get directions use case. Now I will inject these two within our view model. Now I'm gonna create one function, and that function name is get location updates. Here I'm gonna pass my destination, type is lat long, and within this I wanna use my get location update use case, pass my destination, and start collecting the latest changes. So because this thing is executable only within our Kotlin scope, so I'm gonna use my view model scope dot launch and put this thing within our Kotlin scope. Now it works well. So in order to store the location event, I'm gonna create a private val current location, type is mutable state flow, and the type is location event. Okay, mutable state flow, and I'm gonna use location event dot ideal for its initial value. And within this we have current location that we are gonna expose to our map screen. This is a type of state flow location event get current location. Okay, so I think this is a wrong. Okay, now it's good. So this current location is actually telling us the current location. So I'm gonna use this variable here and store the current value. The second function is actually used to get the route. So get directions, and within this I wanna use my get directions use case, and the requirement of this particular use case is start point, destination point, and the API key. So I'm gonna pass start, type is lat long, we have our destination, and lastly we have our key, type is string. Now simply pass everything here. So we have start, destination, and key. Okay, so after getting the result, you will collect the latest emission. Because this correct latest require a Kotlin scope to execute, so I'm gonna use my view model scope dot launch and put everything within this. Alright, so now I will create a variable private val underscore route points, type is mutable state flow, and we have here direction details. So this thing will contain the direction details, and initialize this thing with mutable state flow direction details. We have a variable here which we are going to expose to our Google Map screen, a route points state flow, type is direction details, and simply update this thing with upper one. Okay, so now this route point is gonna update with our latest emission. Okay, so alright, so here we have UI event, so we need to check its type. So when it is loading, error or success. So we have loading, we have error, we have success. So during the case of success, we are gonna update this thing. Okay, so it dot data, which is not null. Yes, so this is a complete implementation of our Google view model. Now this view model is used in our Google Map screens. To implement our Google Map screen, so go to your presentation module, and within this presentation we have Google Map screen. Now within this Google Map screen, I need few parameters like nav host controller, and I want my view model, and lastly I want a place details, which we had already fetched with the help of places API within our places screens. Okay, so now I'm gonna pass that particular details from place screen to our Google Map screen. So go to your place screen, and here if you remember, we attached a click listener to our list item over here. Okay, we got a complete detail based on the place ID, and after getting the result we invoke this particular lambda expression. So what I'm going to do, I'm gonna update our place detail origin. So it origin is gonna update it with the help of lat long, and the latitude and longitude that we receive within our places result, I'm gonna utilize that thing. So we have places result location, not list location, and we have latitude. Just like this, we have places result location dot longitude. Okay, so we successfully updated our place details origin. This is because during the mapping in our data layer, we simply use latitude longitude 0, 0 and 0, 0 to set our origin. Now it's time to update that thing, because in our Google Map screen we want that origin or the starting point. So that is why I am gonna update this thing. Okay, now it's time to pass this particular information over to the screen. So in order to do that, I'm gonna create a lambda expression. Go to Google Map. Okay, this is a function, and within this function I'm gonna pass my place details is information, and the return type is unit. Now I'm gonna utilize this particular function within our clickable event. Go to Google Map, invoke, pass your place details. Now go back to your internal location feature API, and within this feature API we have our restaurant finder screen. Now I'm gonna open a pair of parentheses, and here you will see we got our information place details. Now it's time to pass this thing. So in order to pass this thing, I'm gonna use my nav host controller and its current backstack entry, and in which we have save state handle, and I'm gonna set our information to this particular save state handle. So this thing require a key. So key is place and information is it. But in order to use this approach, you first make this particular place detail parseable so that it is possible. Otherwise it won't be possible without making this place detail parseable. So I'm gonna use my place detail data class, and I'm gonna use parcelize annotation and parseable interface in order to make this thing parseable. Import this. Now it's good. Go to your internal location feature API. Now we simply set our place detail information within our save state handle. Now within our Google Map screen composable, I'm gonna create a variable place and use nav host controller dot previous backstack entry. We have save state handle, and I'm gonna get the type would be place details and key is place. Okay, so we received successfully our place detail, which we attach to our current backstack entry save state handle, which is a previous backstack entry with respect to our Google Map screen. Okay, so after getting our place detail, I'm gonna check whether it is null or not. If it is not null, then I will call my Google Map screen composable within this. Okay, so now the parameter that I need to pass within this Google Map screen is nav host controller and our view model. So view model is not created yet, so I'm gonna create a simple view model hilt view model, and the type of this view model is Google view model. Simply pass that view model, and lastly you need to pass your place details. Okay, so now we have Google Map screen, and within this screen we have our place detail information. So basically we have a starting point, we have destination, we have restaurant name, we have deliveries available or not, everything we have in this particular screen. So now it's time to implement our Google Maps. This I'm gonna create few variables that I will consume within this function. So the first variable is current location, that is initialized from our view model current location, and I'm gonna collect this mutable state in a form of state. Second one is our route, which will contain the information of our route. View model route point, again I'm gonna collect this thing in a form of state. And I require one more variable which basically contain the information of our destination, and that is coming from our place details. Alright, so after getting all this information, I'm gonna use launch effect, execute this particular launch effect for once. That is why I use key as a unit. Now within this coroutine scope, I'm gonna call our view model get location updates function. Requirement of this function is our destination. Alright, so as you know, current location is basically a sealed class that contains 3 more class in it. So that means I'm gonna use one expression here. Our current location value has a type of ideal. Second is in progress. Third one is reach to the destination. So for the time being I am working with this location is in progress state. So within this state I'm gonna use my current location value, and we have location. I'm gonna check whether it is null or not. If it is not null, then I'm gonna execute this block, call this thing location. Alright, so the first thing which I'm gonna do within this block is a camera position up state. So remember camera position state, and I'm gonna open a pair of parentheses. Within this we have position, and that position is updated with the help of camera position. So I'm gonna update our position with the help of camera position. We use its builder. Now we have few parameters that I want to show you an image, and on that image I will explain you what are the things. Like we have zoom, we have bearing, and we have tilt. Okay, and lastly we have our target, and simply build it. Okay, so I'm gonna tell you about zoom, about bearing, about tilt, about target. So just look into this image. Okay, so this is an image. The plane is representing our earth. We have a target. So here you will see this is our target, and this is the intersection of our perpendicular which is coming from our camera. So you will see this one. Okay, so this is a perpendicular to our plane from camera, and the angle is subtended from this axis to the target. Okay, so the line from camera to our target, so this will subtend some angle from this perpendicular, that is called tilt. Okay, so when it's come to bearing, bearing is an angle that is subtended from our north pole and our target from this intersection point, like you will see over here. So this angle is called bearing. Now I think you got what I'm trying to say, and if you don't got, don't worry, I will put this link to the description. Go and check everything by yourself. By the way, it's very easy. If you don't understand, I don't know why you you don't get it. It's very easy. And when it's come to zoom, in the bottom you will see the zoom. So the value of this zoom representing, if you put 1, it will show you the whole world. If you put 5, it will show you landmass, continent. If you put 10, it will show you city, a street for 15, a building for 20. Okay, so within our application, the zoom level which I prefer is 17f. Okay, now bearing is something which is coming from our location, so I'm gonna use my location bearing, and I will use tilt 45 degree. And when it's come to target, so I'm gonna use again my location, but this time I will create an object of lat long, use my location latitude and my location longitude. Yep, so I have successfully updated my camera position in initial phase. Okay, now what will happen if we update our position, current position, like if I present on 0 comma 0, now if I move to 0 comma 1 or 0 comma 2, whatever. So how do I update my camera position? So in order to do that, I'm gonna use my camera position animate, and within this animate we have update. So we are gonna update our camera position with this camera update factory. So we have camera update factory, and within this we have new camera position. Okay, and the second parameter within this animate is the duration. Okay, the animation duration. So I'm gonna choose 1 seconds. Okay, so now within this new camera position, just click Ctrl P. You will see it require camera position. So just create a camera position like we did already. So camera position, instead of doing that, I'm simply copy this thing and paste over here. So copy this, paste over here. Okay, so everything is fine. Alright, so this is a way using which you will animate your camera and update your location. Sorry, update your camera based on your location. So this animate is a function that will execute within a Kotlin scope. So I'm gonna create a scope for that. So while scope, remember coroutine scope, and I'm gonna utilize that scope here. So scope launch, and within this I put all these things. Okay, now we hit our initial phase of camera position. We did, if our location got update, then we update our camera position. Now we also need to show the polyline in our map, like from current position to the restaurant we want to show the polyline. So in order to do that, I'm gonna use my launch effect, and this launch effect is basically based on our current location value. If our current location value change on that occasion, we are going to execute this block, and within this block we have view model get direction. So basically this will provide you the route points, and within this we have start. So within our start, I'm gonna use my lat long. We need to pass our location latitude here and location longitude here, and we have our destination. So in place of destination, just pass your simple destination. Oh sorry, I passed my destination within this latitude and longitude, so sorry for that. Pass your destination over here, and lastly you need to pass your key. So I pass empty string. Cool. So based on our current location, if our current location updates every time, we trigger this get direction. Now if our route is updated, so we need to update our polyline. So in order to do that, I'm gonna use again a launch effect, and in this time I'm gonna use my route value. If this route value will update, so on that occasion I'm gonna first update my camera position and then update my Google Maps polyline, so which I will create. I'm not creating that thing yet, so I will create that thing too. Okay, so everything is done. Now within this launch effect, I'm gonna use Google Map. Now requirement of this Google Map is modifier, so I'm gonna use modifier fill max size, and we have our camera position. So camera position is coming from our camera position. So camera position state, I think, yes. So we have camera position state, and within this camera position state I'm going to send my camera position which I created over here. Okay, now open a pair of parentheses, and within this I'm gonna attach my polyline. So polyline, requirement of this polyline is points. So the point is present within our route value points. Apart from this, we have its width, its color. So I'm gonna use color blue, not black, it's blue, and lastly we have width, so I choose 20f width. Okay, cool. So now everything is done. So the thing which is left from my side is the connection from this places search to this screen. So in order to do that, go to places search. Here within our clickable events which is present in our list item, I'm gonna navigate from this screen to other screen. So I need our nav host controller. So go to your internal location feature API and pass your nav host controller from here. Go back to your places search and within your add nav host controller. Now I'm gonna use that thing just below to our Google to go to Google Map invoke. So I'm gonna use my nav host controller, navigate location routes dot Google Maps dot route. Alright, so connection is also done. So this now it's time to execute our application. Everything is done from our side. We have Google Map screens, which is perfectly fine. It's time to check whether it is running exactly what we expected or not. So let's run this thing. Alright, so during the execution of our application, I found few issues which is purely related to our plugin. This is not our issue. So here it will create a step data class, and within this we have duration of type duration x. So actually it will create a duration type, but here I don't know why it is creating object of duration x or end location x. So remove x from these objects and simply execute your application. Application executed successfully. Alright, so this is our search screen. So I'm gonna click on these three dots and it will open this interface. So within this interface you select location, and within this single point tab you're gonna choose any location which is very near to you. I'm choosing this one and set my current location of the simulator to this. Cool. Now I'm gonna type a restaurant which is very near to me. So Kisori is a very near restaurant from my current location. So I'm gonna type this and there we go. We have this restaurant. I'm gonna click into this, and yes, this is a route. Now I am going to start moving to this restaurant. So I'm gonna play my route. So here you will see we have a route tab. Click on this route and you need to search the Kisori. So I got this Kisori restaurant. Click into this, start our route. Go back to your single point again, select this location, copy the location address from here, go back to your routes and put it your start destination. Alright, now choose your speed, it's up to you. So I am gonna choose 2x and play my route. So it will update our location, and based on that location our route is also start updating. Okay, so the difference which you see is actually present because I start my routing from Bhagwa Chungi, which is more near to the restaurant, and my current location is more far. So that is why it will start from the middle of this route. So there is no problem with our logic. Our logic is perfectly fine. There is a few issues regarding this route, so that is a case. Okay, so when I reach to the destination, it stops the execution. Just wait for it. I'm gonna increase the speed to 4x. Okay, so this is a use of bearing. Actually the camera is present just behind you, and all of this camera moving part is handled by our bearing. So that is why bearing is so important. Alright, so we successfully reached to our destination. Okay, so this is a thing which we have done it perfectly. So now it is a time to insert all of our place detail in a local database. So in order to create a local database, we are going to use a room database library for that app database present in our application module. Now this is because application module knows all of our feature module. So any data object which is specific to any feature is available in app module, and by doing this we are very easily provide all of the implementation for data access object. And apart from this, with the help of dependency injection, we also provide the data access object to our application, so that we inject anywhere we need, like fragment, activity, use cases. So now it's time to write our app database. So within our app module, I'm going to create a package, app database, and within this app database I'm going to create a abstract class naming app database. Okay, extend this with room database and make sure to convert your normal class to abstract, and annotate this with database. Within this we have entities which we are gonna insert in our room DB. So in my case we have place detail. Need to pass our version code, which is version number, which is 1, and I don't wanna export my schema, so I'm gonna use export the schema as a false. Within this I'm gonna create a companion object, and within this I'm gonna create a function get instance, pass context here, import this context. Return type would be app database, return room database builder, pass your context, your database type, and your database name. So I just simply call DB, and I don't want to write any migration, so I want to use fallback to destructive migration and simply build it. Okay, so this is a normal application database in our case. Go to your location feature domain layer, and within this I'm gonna create a package. That package name would be a room, and I'm gonna create a interface, or you can say data access object. So location DAO, this is an interface, and make sure to annotate this interface with DAO. Okay, so I'm gonna use suspend function insert, which we use to insert our place detail, and make sure to annotate this with insert on conflict strategy replace, so that it will replace the older primary key. If we have two data or two record which have a same primary key, then the older one is replaced by the newer one. And the second one is query, which is used to get all of our information from DB. So select asterisk from place details. Okay, and I'm gonna use flow here, so don't use suspend keyword before function. Function get all place details. Return type would be a flow, make sure to import the correct one, and within this flow it will contain list of place details. Okay, so now it's time to convert this place detail normal data class to entity. So I'm gonna use this place detail in form of entity. So in order to do that, first thing first, you need to use this annotation entity over our data class, and second thing, every entity has a primary key, so I'm gonna use place ID as a primary key, and make sure this auto generate is false, so that our room DB does not create a primary key by itself. Okay, so we have our location down. Now it's time to write implementation. So within our app DB, we are going to create abstract function get location DAO. So the implementation is written by our room library. We don't take care of this thing. So location DAO. Okay, so now it's time to use dependency injection and provide all these things. So our database is single, so singleton provide function, provide our app database. Requirement is application context, return type would be our app DB. So return app database dot get instance, pass your context. Okay, just like this, I'm gonna create one more function which provide our location DAO. So provide location DAO. Requirement is app database, location DAO, return app database, get location DAO. Alright, so everything is done regarding with our roomdb setup. Alright, only one thing is left, and that is in our place details you will see we have lat long objects. So see, in our roomdb we only save primitive data types. It is not possible to save any complex object just like this lat long and anything which is not a primitive data type. It is not able to save in our records. So what we need to do, we need to write type converter for that. So what we do, we simply convert this lat long into a string and then store in our roomdb. And when we get all of our objects, then we need to convert this string into a lat long. Okay, so for that we need to write few type converters. So I'm gonna write below to it. So class lat long type converters, and within this we have function. The first one is convert any string to lat long. Okay, string return type would be lat long. I'm gonna use JSON here. Within this JSON we have from JSON. So you need to pass your string and the type. So lat long class.java, and the second function is lat long to string. So pass your lat long within this function, and the return type would be string JSON dot to JSON and pass your lat long. Okay, so this will convert lat long into string. Now in order to tell our roomdb that this is type converters, so you need to use type converter annotation. Okay, so now it's time to register this type converter within our application database. So we have one more annotation for that, type converters, and you need to pass your lat long type converters class. That's it. Alright, so now it's time to go back to your location feature domain layer and write few use cases. Create a class, and that class name would be get all place details from local db use case. So within this I'm gonna inject my data access object. So private val location DAO, and I'm gonna use operator function invoke and use my location DAO get all place details. Okay, just like this we need to create one more use case for insertion. So insert place details to local db use case. Inject constructor private val location DAO, and I'm going to create a suspend function invoke. So I need to use operator here, operator suspend function invoke, need to pass our place details, and I'm gonna use my location DAO insert and pass our place details. Okay, so need to sort this one. Yeah, cool. So by doing this we actually write all of our use cases. Now it's time to provide these use cases within our domain module. So provide function get all place details from local db. Okay, and it will provide basically get all place detail use case. So return get all place detail use case, you need to pass your location DAO. Just like this we need to pass our other use case, so which is insert place detail use case. Again requirement is location DAO, and the return type is insert place detail to local db use case, return insert place detail to local db use case and pass your location down. So now it's time to use these two use cases in our presentation layer. So go to your presentation layer, and here within our screen we have Google Map. Go to your Google View Model, and first thing, just use private while insert place detail to local db use case and create a function insert place details. I'm gonna use my view model scope dot launch, and after that I'm gonna use my insert place detail to local db use case and pass my place details. Okay, so this is by doing this it will store our place detail in roomdb. Okay, so now it's time to use this thing within our Google Map screen. Alright, so when we reach our destination, I'm gonna use view model insert place detail and pass our place. Okay, and after that I'm gonna use a toast message. So toast dot make test, I need to pass a context, so I don't have context within this composable, so I need to create context. So context local context dot current. Now I want to use that context here. I need to pass message that reach to the destination. Okay, so I need to pass the duration, so which is toast dot length long, and simply show it. Alright, and after that I'm gonna use my nav host controller, and I wanna pop up stack, and I need to pass my destination. So my destination would be this place search, this one place search. So here if you see in our composables, we're gonna use this location route. So we have location route Google Maps dot route, we have location route places search route. So I'm gonna use this places search route and go to our Google Map screen and pass here. Okay, so this is our route, so need to check. So you can pass your route. The second one is inclusive. So yes, I wanna pass this true because I want to remove the Google Map screen and places search screen from our back stack. Okay, so that is why I am passing this inclusive is equals to true. Alright, so when we reach to the destination, we simply inject, or you can say save our all of the details for the destination in our roomdb. Now it's time to use that information and show to our user on our dashboard screen. So go to your dashboard feature, and here we have presentation. Now this presentation doesn't know about location domain layer, so we need to connect that. So here within its build.gradle, I'm gonna use location domain and sync it. Go back to our dashboard feature presentation, and within this I need to create view model. So I'm gonna call this home view model. This is a class, and this class extend view model. Okay, hilt view model, and I'm gonna use inject constructor private while get all place detail from use case, and simply I'm gonna create a variable list and use this get all place detail from local db use case. Okay, yeah, that's it. Now it's time to use this list within our home screen. So within our home screen I'm gonna pass nav host controller home view model, these two things. Okay, so now it's time to use this home screen within our navigation thing, internal dashboard movie API. So here within our home screen we need to pass two things, nav host controller and the home view model. So we already received this thing. and home view model is not created yet, so I need to create one. So home view model, this is generated with the help of hilt view model. Need to pass our type, which is hilt view model, and pass your home view model. Okay, yeah, that's it. This is all for our navigation setup. Now go to your home screen. Within this home view model we have list, so I'm gonna create a variable again calling this thing is list home view model dot list dot collect as state. Okay, and when it's come to initial, just pass empty list. Yeah, that's it. So I'm gonna write my UI then. So I'm gonna use scaffold, and here we have top bar, and within our top app bar import this top app bar, and within this top app bar I'm gonna give title as a text home page, and apart from this, let me just reformat it. Apart from this we have actions, and within this action I'm gonna create a icon button. So we have on click, and within this I'm gonna use a icon. Import this icon. I'm gonna use this image vector one. So icons dot default dot search, and the content description is null. Alright, so yeah, that's it for our top app bar. So this top app bar is experimental API, so I need to add this annotation on the top. Alright, so I'm gonna use logcat to remove this error. This is because we don't use padding values, so that is why it will give me an error. Okay, so now it's time to check if our list value is empty or it is not. So if it is empty, I'm gonna create a box modifier fill max size content content alignment is on the center, and within this I'm gonna create a text that no destination found. Import this modifier. Okay, so this is a case of when we receive a empty list. Okay, and when we don't receive a empty list, then I'm gonna create a lazy column, and within this lazy column I'm gonna use items, and within these items pass our list value. Let me import these items. Okay, so now we receive one by one our place details. So we need to create our list item. So I'm gonna create a location list item, and the input of this thing is place details. So I'm gonna create this composable below to it, location list item, and the input would be place details. Okay, and within this I'm gonna create a column. So modifier fill max width, and padding is 12 dp. Okay, and within this I'm gonna create few text and few spacers. So the first one is text. This is a starting point. So we got starting point from places detailed origin latitude and its longitude. So it origin longitude. Then I'm gonna use spacer modifier, and I'm gonna use height of 8 dp. Alright, so just like this I'm gonna show you the ending point, or you can say destination. It dot destination dot its latitude and its longitude. So it dot destination its longitude. just below to it we want some space, so I'm gonna use modifier. Its height would be 8 dp. Okay, then again I'm gonna use text, and this time I'm gonna use it dot its name. Okay, and on the starting I will call this thing as name. Again spacer of 8 dp. So modifier, we have height of 8 dp. Again we have text, and we're gonna check our it dot, we have a rating here, so a ratings which is coming out of 5, and on the start we call rating. Again I'm gonna use spacer, give height of 8 dp. Again a text, so this time the text would be a depend. So if our it dot delivery, if it is true, then we call this a delivery is available. If it is not, then no delivery available. Okay, again I wanna use space, modifier height of 12 dp, and we should also use this spacer on the top. Okay, so this is our location list item, and this is our simple, very simple home screen. Okay, so now what will happen if we click in our icon button, then I want to use my navhost controller, navigate here. Yes, it is available. So location route, places search route. So basically when we click our search icon, we simply navigate to places search. Okay, so this is a very simple use case of this navhost controller. Alright, so now go to your app date application module navigation, and here we have main navigation. In our main navigation we need to change this location route, so click on this. You will see we have dashboard, we have location. So now it's time to set up our dashboard. So go to your main navigation again and just convert this location to dashboard, so that our first screen would be dashboard screen instead of our places search screen. Okay, so yeah, that's it. Now it's time to execute our application and check whether it is properly working or not, and if any error will be occur, then we will solve together, no worry. Our app executed successfully. This is our home page, and when I click search icon, we will reach to our places search screen. So first thing, I execute this application for the first time. Then we need location permission, so I'm gonna give this permission, and after that I will click on these 3 dots which will open this UI, and by using this location thing you will update your emulator location. So I'm gonna update my current location of this emulator to Kisori Southern, and I will choose set location, so it will update my current location. And here I'm gonna type Kisori, so it will give me the Kisori restaurant. I hope it will give, and there we go, we have Kisori restaurant, Bela Pratapgarh, UP, India. So I'm gonna click it, and it will start the direction API. It will call direction API, establish a route from Kisori Southern to the Kisori restaurant, and there you go, you will see all the direction thing over here. Okay, so now again I'm gonna open this, and I will create a route from this point, from our current location to the restaurant. So I already did this from before executing the application. So this is our route, and I'm gonna start routing. Okay, so it will start routing toward our restaurant. So just like this, it will update our UI also. So after we finish our execution, the information is gonna save in our room DB, and will again reach back to our home page. So wait for the moment when we reach toward our restaurant. So I'm gonna increase the speed 5x so that it will move quickly. Okay, now I'm gonna reduce my speed. So we successfully reached the destination. That information gonna saved in our room DB, that is reflected in our home page. Okay, so I did more changes in order to get this Kishori restaurant name and this rating. So that changes were over here. So here I need to add these two fields so that I got the name and rating. And one more thing, when you open this to domain function, you will see I update this thing with empty string. So what I need to do? Okay, so I'm gonna control click over here, so it will tell me I'm gonna use this thing over here, and within this to domain function I'm gonna pass my place ID. Okay, this place ID which we receive from our use cases. So I'm gonna call this, and over here I'm gonna create a parameter place ID which is a type of string, and yes, it may be null for some time, for few times, not sometimes. So I'm gonna use my place ID, or if it is null then I'm gonna use empty, so or empty. Okay, now it works fine. Okay, so by doing this you will update your place detail ID. So if you have a different ID, then you have a different entity in your room DB. Okay, so that is why I will update my place ID. Alright, so that's it. This is all for this video. I think this video is very long, and at the same time it is very informative for those who never did multimodularization, never use Google Maps, and never use location, all these stuffs. So yeah, this is all for this video, and if you have any query, anything which I left during this flow, then you will told me everything in the comments. Okay, so thank you for watching this video. If you watch this full video, then thank you for believing me. Okay, so bye and happy coding.